of the damper is to reduce the speed or the velocity of the what? Of the moving system. So what you see in a dashboard, what does it really look like? Is you have a cylinder in 2D, okay? And then you have what? You usually have a piston, and then you have what? Oh, don't go there. You have fluid or fluid and particle mixture. Okay, that's what they are doing now. Okay, and then if we were to draw this expression over here, so you have F and you have velocity over here, you tend to have a linear relationship looking exactly like this. Okay, so the expression we can write is force is equal to C multiplied by velocity. And if over here, this is our y distance, so this will be equal to C dy by dt. Okay. So where F is the what? Applied force. And then we have dy by dt is our velocity. And then finally, C is our damping coefficient. Okay. So if we were to look at the units, right? On the left-hand side, okay, by looking at the units, on the left-hand side is Newton. And then I have not a clue what is C, right? Let's say I put down here, I have not a clue what is C. I put down here, not a clue what is C, question mark. And then our velocity is in what? Meters per what? Second. So C, the unit for C is what? Newton second per what? Meter. We clear? Right? We just move the units across. So we know that applied force is in Newton, velocity is in meter per second, damping coefficient is in Newton second per meter. This is what we call balancing of equations. Okay. So so what we do to change the damping coefficient, okay? If it is real straightforward, for example, you can just an illustration. You can put water or you can use what? Oil. Are we clear? If you use water, so let's compare water, oil. I'm not saying mercury is a good fluid to use. Okay. So what happened is when you move from water, oil, or mercury, wait, yeah, I'm pretty sure. So over here, the damping coefficient increases. Okay. When the damping, so for example, this is C for water. And then if it gets steeper, okay, this is C for oil. Okay. Can you all, I do apologize, my bad. Okay, can you all go back to over here? All right. So if this is for not here. Let's say if not this graph, I do apologize. Can you all go to the stress strain curve? So if this is E for brass, okay, the E for steel will look like this. Okay, the gradients get steeper. Okay. So if you want to change your damping, okay, one of the easiest ways to change your what? The fluid inside. Now there are technologies that they use what? Fluid mixed with what? Particle. This particle outside the cylinder and they will pass through a voltage current and this magnetic particles get magnetized and increase the what? Viscosity. Okay, clear. Like that's what they're doing for cars now. Okay, you can adjust the damping depending whether are you racing or you driving on a normal street or you want your bones to hurt. There you go. The last thing on a mechanical system is the mass. Okay, it's the mass. So the bigger the mass or the larger the mass, the higher force is required to achieve a certain magnitude of acceleration. And based on Newton's second law, what we have is F is equal to MA, and this is equal to M d squared Y over dt squared. Okay. So because we are under motion, okay, so the kinetic energy in the mass is basically the kinetic energy is equal to half mb squared. And we all know that. Okay. Okay, now let's go into, so let's assemble them everything together now, okay, and see how it works. Okay, so next thing that we're going to do, I'm going to introduce you to okay, we're going to look into the characteristic equation for a damped, unforced vibration. So for a damped, unforced vibration, what we have is we have structure, we have a spring, and we have a damper, and down here we have K, we have a C, and then we have our M, which is our mass. And then from here, we will have Y. Now, Y is the what? Y is the displacement. Are we clear? Okay. So next, beside that, whatever we analyze, okay, we have to have our Now, and I need to tell you something else. This is okay. When we draw this, means we already include what? Okay, where G is 9.81 meters per second squared, M is the mass. Okay, we already included. Okay, so everything at this stage that we draw is at its what? Equilibrium. Okay. Then next, we are going to construct a FBFBD. Okay, so for the FBFBD, again, we have our mass. Okay, and then we are aware that over here, we have a reaction due to the spring, which is equal to Ky. And over here is equal to Cy dot. Okay, and now down here, the motion that we want to look at is Y over here. Are we clear? Okay. Yes. You're very impatient with me. Be patient a bit, okay? Wait, our derive more, okay? But a snapshot is if the structure is over them, there's no oscillation. If the structure is under them, you'll see an oscillation. Okay, be patient with me, okay? Okay, he don't look happy at all. If now, okay, I were to reduce this to 10, okay, I reduce this to 10. Can you see what's going on, right? So, ladies and gentlemen, what I'm doing down here is, yeah, I know this is mathematically, okay, but can someone tell me the color of that line? I'm partial colorblind. What is it? Orange. Thank you. That's why I can't do chemistry, okay? They ask me, Eugene, after mixing the fluid, what is the color of it? Like, really? Sometimes I want to drink, but I can't. But anyway. So if we were to change the damping coefficient to 900, you see what happens? Right? The oscillation, does that answer your question? The oscillation like die off. I mean, this is not steady state yet, okay? So if I were to be more gentle, like 200, okay? 200, you still have damping, maybe like 1. Or if I reduce the mass to 9 and I put this to 200, right? Okay, so I hope by Monday, the latest, you all can like produce this graph on Excel on your own and really know what it means, because this is mechanical engineering stuff, okay? Not any other department. Right, any other questions? That's a good question, okay? Any other questions when we go back to our slide? Anyone? So I only, what is another term on this sheet that you see that you don't understand? What is it? Anyone? Yeah. Yes. No. I did. No. I want this to. No. I want this to be a nice learning environment. If you have question, we ask. Okay. I just trick you guys, and you guys are not asking. What does FBFBD means? Hey, what does FBFBD means? You FBFBD when you are in my course and when you're in Dr. Koshi's course and when you do P03 later. What does FBFBD means? Freaking big free body diagram. Are we clear? Don't draw me a free body diagram that is small. Are we clear? Okay, whenever you draw free body diagram, it has to be what? Big. Are we clear? The bigger it is, I'm not saying that you go ridiculous, okay? We have to do FBFBD, which is equal to freaking big free body diagrams. Clear? So if anything that you see that's written on the board that you don't understand, what do? Ask. Are we clear? Okay, I will throw you all some tricks like that. And if you don't ask, you lose. Okay. So that is our